Alright, so we started talking about on Monday derivatives of exponential and logarithmic functions. Alright, meaning we talked about e to the power of x, or more general cases e to the power of q, and we also talked about the natural log function. Alright, and we came up with the fact that if we had the derivative of e to the u power, it is equal to e to the u times the u dx. This stuff, you already wrote this down. And the derivative of the natural log of u is equal to 1 over u times the derivative of u. Alright, so what we need to look at now is a couple other cases. Okay, we need to look at what about if the base. So you probably should have talked about this first. What is the base right here? E. And then what is the base of the natural log function? Like, so you know how usually we have like the logarithm base log base 2 4 or something. What is the base of the natural log function? The base is E. Base is E. So the base of the natural log function is E. Alright. So now I want to go over just a few of these. Alright. These types of derivatives. So right here, we already know this one. What is the derivative of e to the x? E to the x. Alright. What about if we had the derivative of x to the e power?
What does the x mean?
No, because is e, what is e? E is a number. So now that x squared would be 2x. And then we subtract 1 from 2. But this is e. So what would we, if e is a number, what do we do with that? E is an x, so no. So e x is e minus 1 power. It looks a little weird, but e is a number. When we have x raised to a number, we bring that number out in front, multiply it, and then we subtract 1 from the exponent. Okay. What about the derivative of ex? Nope. E is it's just e, because e is a number, so it's essentially the same as like 2x. So derivative of e to the x is e. And then what about the derivative of e to the third power? Nope. What is the derivative of? First of all, is e a variable or is e a number? So it's e to the third power. So that'd be like saying 2 to the third power is 8. So what's the derivative of 8? 0. So the derivative of e to the third power would be 0. Okay. Now, what we were doing is we were working with exponential functions that only have the power of e. Right? But we all know that we're going to see exponential functions that look like this: 2 to the x or 5 to the x. Okay? We're going to see functions where the base is not e, and we still have an exponential function. So we need to know how to take derivative of that. Now, a couple things to help us. All right, and these are sort of these are from pre-cal, way back in the beginning of pre-cal. All right, these are properties of logarithms. Okay, these are things that you don't necessarily need to know, but they will make some of the problems easier. All right. So we have two properties here. The first property is where you have something that looks like it's log base b of n to the p power. Right? And what you can do here is this property allows us to say that we can take this exponent right here and bring it out to the front. So we get this is equal to p times log base b of n. All right. For instance, we had something like this, log base 4 of x squared. rewrite that as 2 log base 4 to the x, which would make our lives easier. Why would it make it easier? Because it's probably going to eliminate us having to use chain rule. Okay. This other one, log base b of a, it's nothing really crazy, but the thing is, in our calculators, we can't actually type that in, right? And what we have is something called change of base rule, which allows us to say log a divided by log b. All right. Okay. So an example of this, you can make log 3, log base 3, 5. That is equal to log 5 divided by log 3. Alright. Now, we'll keep those in our back pocket. Those are some things that you may want to use down the line. Okay, now, what I want to do first is I want to look at exponential functions with the base other than e. Okay? So, what we have here is we want to find the derivative of a to the x power, where a is some number, right? A is something that's not e. Okay? So, what we have here is, first of all, we know that y is equal to a to the x power. The equation is taken. So we know y is equal to a to the x power. Alright. Now, what we can do here, this is drawn back on some, some freak out, is we can take the natural log of both sides. Alright? Why would we do that? Because we aren't really adept at working with exponents that have x in them. Right? So by taking the natural log of both sides, what we're going to be able to do is use this right here. Alright? So we're going to take the natural log of both sides. Natural log of y is equal to natural log of a to the x power. Now, the natural log is, all it is, and the reason we use natural log is because we know how to use that, we prefer natural log of base b, right? It's easy to work with, right? Because we know what the natural log is. So, what we do is we apply the property that for logarithms, right? Because natural log is just a logarithm of base e, and we bring this x out front. The natural log of y equals x times natural log. Okay. All right, now I want to point something out. This is not how you find the derivative. We're going through the work that shows us what the derivative of a to the x power is. Okay. So the natural log of y equals to x times natural log of a. Okay. So now what we're going to do is we're going to differentiate this. All right. We started here. This is our original function. We got it all the way here. This y equals a to the x power equals to the natural log of y, which is equal to x times the natural log of a. Those are the same expression. So what we're going to do now is we're going to differentiate it. And we know, and this is going to involve this differentiation. All right. So what was the derivative of the natural log of y? Okay, so you have 1 over y times what? dy dx. Because you already, whenever you have a y involved, differentiating, and you put some differentiation, just multiply by dy dx. Alright? That's equal to x natural log of a. So what would the derivative of that be? Nope. Just keep in mind that x times natural log of a, where a is a number. So it's like the natural log of 4. What's the natural log of 4? Is it a number? It is. It's a number you have to look on your calculator again. So natural log of 4 is a number, so it's a number times x. So it's some number times x. What's the derivative of something like that? The number. So the derivative of this is natural log of a. Alright? So what we do here is we're going to multiply both sides by y. That's going to give us dy dx is equal to y times natural log of a. Okay, well, almost there. We don't want a y over here. Do we know what y is equal to? Y is equal to a. Did you say something after a? So y is equal to a to the x power. So the derivative is equal to a to the x times natural log of a. Okay. So let's sort of generalize this into, well, what is a to the u power for u something? Alright? So the derivative of this, so right here, this is the derivative of a to the x power. Every time. No matter what the number a is, 4, 5, 6, 7, 8, no matter what it is, that's the derivative. It's just, so let's say you had 5 to the x power. Okay? Find the derivative of that. The derivative would be 5 to the x times the natural log of 5. Done. The derivative of 5 to the x of this. Alright? Want to see that crazy? Alright, you can see it here. So let's take this and, give us a general rule. General rule. d dx of a to the u power. Alright, is going to be a to the u times natural log of a times, just use another function. So they have to take the derivative of u. Alright. Sounds, what do you guys think? This one sounds hard or easy? You said that, haven't memorized. Alright. So, let's look at some examples. The derivative of 2px minus 3. We have two terms. We're going to take the derivative of each term. 2 to the x power is equal to what? The derivative of that. It's going to be 2 to the x times natural log of 2. Minus, what's the derivative of 3? 0. Okay, so there's our derivative. I don't have to multiply by the derivative of u because the derivative of u, use the exponent. The derivative of x is 1. Alright. So, let's look at this one. So, the derivative of 4 to the x squared power is going to be, what are we going to have here?
Or is it squared?
Or to the x squared power
Times
times
four
natural log of 4
times 2x.
times 2x. Alright, done. What's the derivative?
You don't have to simplify these.
No. Yeah, just like that. The only way that this could be simplified is they may have like 40 x to the power times 2 exponential log of 4. Alright, the derivative of e to the x. What is the derivative of e to the x? Alright, but let's do it all the way through using that same rule and see why it's e to the x. So we go e to the x times, alright, natural log of the base times, well, 1 because that's the derivative of x. What's the natural log of e? No, natural log of e is just equal to 1. Natural log of e is a number. Natural log of e is equal to 1. Natural log of x. Alright, this natural log of e is just a number, and it happens to be 1. So that would be equal to e to the x. That's why e to the x is equal to the derivative of that is equal to e to the x. Alright. Shamar, what about 3 to the sine pi x power? So look at me first. What? You said 3, I didn't hear you.
Oh, we can find out on,
That's what it would be times. Sine pi x. Times pi. You get it? You got that? You got this part. First thing you do is you just repeat what you have. Times the natural log of the base. Then you take the derivative of the exponent. Sine pi x has changed. Okay. Yeah. Look at this one. X squared to the 10, or x squared times 10 to the 1 minus x squared power. So this one has product rule in it. So it's going to be u times dd. We have to take the derivative of 10 to the 1 minus x squared power. So here, what was the derivative of 10 to the 1 minus x squared power? I didn't teach you stretch. Here, look. What would be the derivative of 10 to the 1 minus x squared power? What is the derivative of that? No. What's the first thing that we ought to do? It's product rule and chain rule.
bring that out.
So hold on. Guys, don't think hard. All we do is first thing we do is we rewrite that exponential. So it's 10, I'm going to put 10 times 10 to the 1 minus x squared power. Then I multiply by the natural log of the base times natural log of 10. Okay. Then I multiply by the derivative of exponent. So what is the derivative of minus or 1 minus x squared? I get 2x and then multiply by 2x. Alright. Now I add b du. So it's going to be 10 1 minus x squared power times the derivative of x squared, which is 2x. So what do I get here? I get negative 2x cubed times natural log of 10 times 10 equals 1 minus x squared power plus 2x times 10 equals 1 minus x squared power. I could simplify it somehow. Questions about that?
Yeah.
Where?
What is, what is this right here?
What?
That's view, and then what's the next part?
Where?
That next part.
Here?
No, that's not,
Here?
yeah.
Here? Each up. This is like, that's you. This. That is all the derivative of the.
Okay, all right now. And that's V, that's view.
Yeah.
Okay, no.
Questions? Here? Other problem at all?
Yeah.
Yeah, homework. You guys are gonna practice, you guys can practice sheet work on class on Friday. That's more so for this. How's that?
All right.
Oh. Oh.
Oh.
Alright. So, we have, okay, so what we're going to do here is, again, we're going to take this and say, we have, so we're going to rewrite this, right?
Okay.
Actually, y is equal to, and we're going to rewrite log base ax using the, or change the base formula as natural log of x divided by natural log of a. Okay. So, now we're going to take the derivative of this. Look, let's rewrite this real quick. Alright, natural log of x divided by natural log of a is really saying 1 over the natural log of a times the natural log of x. And the reason I write that like that is I want us to sort of realize and understand 1 over the natural log of a, that's just a number. Alright, so that's like a coefficient. Alright, so we have, so take the derivative of both sides. Is dy dx is equal to, so this is just going to be that constant stays there, 1 over the natural log of a times with the derivative of the natural log of x. Okay.
I'm gonna switch it.
I know. Now we do things. Now we can just combine this. We get 1 over x times the natural log. And there you go. That's how you do this. So let's extend this to a case where we have the function within a function. And I'm taking that.
How's it wrong? Can you go to your class? Hey, Snowball.
Yeah.
This is
Yep.
what I said, there is a law of whatever, this right here, one of our.
Yeah. Right, you got to do that.
How do you say that?
Law of base A.
Okay.
Now, we want to extend that though to when we have a function in there. So something like log base A like squared, something like that. To do that, what we would have is 1 over x times natural log of A times dx. Yes. So it's going to be right up here. It is 1 over x times the natural log of A times dx. Alright? So, this is A, that's U. Okay? A, U. So, yeah, it should be U. So, here we go. First thing we're doing is 1 over U. So what is U? 1 over 2x minus 3 times, what is the natural log? What is A? 3. So times natural log. Alright. Now, after that, we take the derivative of U. So the derivative of U would be what?
So there is 32.
2. So our answer is 2 divided by 2x minus 3 times the natural log of 3. I'll let you guys try this next one. Log base 7 of x squared.
You want us to write on the board or on paper?
Sure, you can write it on the smart.
Oh, you want to do it? You want to do it, so.
I want you to find the derivative of log base 7x squared.
So 2x would be? Oh, wait, no, never mind. I did it.
Ready?
I mean, okay, so this one like this, 1. Oh, you know what A and U is? A.
What's that?
Okay.
What's U?
X squared. So, I'm going X squared times another log of X.
Yep.
Times the derivative of this, 2.
And this simplify that, you just multiply, yep, 2x over x squared times natural x. Actually, simplify that one more step, one more.
And you get rid of the x.
Get rid of the x on top and then the x squared to circumvent x. Alright, Kira. But yeah, I'm gonna help you. Alright, so whenever we see square roots, we want to take the derivative of them. We should probably turn it into 1/2, or in this case, 1/3. Because a cube. Really, Kira, what you're finding the derivative of right now is d dx is equal to log base 4 of x. Go! Yep.
Yeah, there are. Yeah.
Okay, times 1/3.
You gotta simplify that.
Oh, you got times 1/3 there. I need to take the derivative of x. So that 1/3 would be there, yes, but.
Oh. You. One-third.
Now, simplify this a little bit. And I give this equal to that equal, alright? 1 x to the negative 2, I don't know what I'm telling. That 3, since it's 1/3, and 1 divided by 3, that should go on the bottom now. X to the 1/3. You can just watch and find out what we'll get there. Alright, now, want to see a way to make this tab make easier? To make it a little quicker? Alright, so what we could have done is taken this 1/3 and brought it out front. And that would give us 1/3 and making it a derivative of log 4. That's 1/3, and that's going to be 1 over what? U. You can do like this. Alright, surprise. Alright. Actually, it would work. Maybe 2/3 minus 1/3.
Now.
Want to see how it works?
Let's see these left ones about that.
Nope. So, you have 1/3, and it'll be times 1 over x times natural log of 4. I know. But then I got concerned, no, it doesn't look the same as that one, why not? Then I saw and realized that if we continue to simplify this, we have a negative exponent up top, right? So like that, so it's equal to, we bring that down and be 1 over 3 x to the 2/3 times x to the 1/3 times natural log of 4. These two combined, add those 2/3 with 1/3 is 1, 1 over 2x natural log. Wish I was oh, that one? What is it?
No, why didn't you do that when I wrote it? I rewrote it.
Alright, well, here we go.
You read that for
Q group, so we have D, log 4x. Alright, so we have to take the derivative of this. Alright, so we make this 1/3 out front, so we do 1/3.
how you want it.
No, I'm not doing this. Right? This is the derivative of log base 4 of x to the 1/3 out. So I'm bringing this 1/3 out. Just like I know it's the power. I bring it down, I subtract 1 from it. So it's 1/3 times log 4x. Alright? 1/3 minus 1 is going to be negative 2/3. And I'll multiply by the derivative of this inside times 1 over x times the natural log of 4. Alright, and that can simplify into log 4x negative 2/3 power divided by 3x natural log. Question.
Yes. The log thing, 1/3 comes to 1 over 3.
Yeah.
What is that?
So that's like this chain rule here. So it's this logarithm to 1/3 power. So you have to take the derivative of the outside first. The outside is something to 1/3 power. So it's something to 1/3 power. So 1/3 times that something.
And then the derivative is on it.
Then take the derivative of x. All right. This one right here. All of this.
I don't think we do. Hang on. We have a test by school break. You know, quiz next week. Every Friday. Oh, I'm sorry. I was Wednesday anyway. Oh, sorry.
Alright, so here we go. So we're gonna take the derivative of this. So this is A, that's u. So we're gonna have 1 over x over x minus 1 times natural log of 2 times. So you gotta take the derivative of it that way. Alright. I'm in doubt. I'm in doubt about what rule is this?
What is, wait, what's the letter? No.
Whatever. So,
So you want the whole thing of you.
I'm saying that whole thing. So, it's taking the derivative of that. So right here we go. This is U and that's V now. They're pushable. So it's gonna be V and VU, which is 1, minus U and VV, which is 1, and then over x minus 1 squared. That's equal to x minus 1 minus x over x minus 1 squared is equal to 1, negative 1 over x minus 1 squared. So that whole derivative is minus 1 over. Alright. So what that would give us, let's see how this is simplified. 1 times negative 1 is negative 1 divided by x over x minus 1 times x over 2 times x minus 1 squared. Well, this x minus 1 and that x, one of those x minus 1 as well. So these are the negative 1 over x times minus 1 over. So these are the negative 1 over x times x minus 1 times minus 12. I needed but. Questions about that?
No?
So, your questions? Or your homework?